Okay, so for the sensor of inspection system 1, in the grading system, imaging technology and NIR technology are essential in performing external and internal inspection. So in this section, the color monochromator and X-ray imaging example and the NIR spectroscopy will be described in here. So machine vision is a common technology used to inspect the appearance in many research fields. And generally speaking, any machine vision requires good illumination, image acquisition hardware, and the image acquisition software, and processing for feature extraction and understanding. Okay, so you can see here, for an image system, basically you need, first thing is illumination. You need a light source. Okay, so that's the first thing. Second one is your acquisition hardware, such as your camera, your lens, and your capture ball, which for analog to digital transform, right? And the PC, your personal computer, and cable between the camera and the capture ball or PC. So that's all belong to the hardware part. And the third one is the software part. So you need acquisition software. And the last one, which is the most important, is the software or your algorithm or your application to extract the feature and to understand the quality around or related to the feature, related to this extracted feature from the image one. So, in full grading facility or post-harvest operation, it's necessary to handle various type of product in different sensor. So you have a image, and you have a NIR, and you also have other sensors. Okay, so their property depends not only on varieties but also on growing environmental condition. Okay, yeah. So here showing the various fluid image. A is a filtering monochromator image. So this one, A is here. Okay, he's showing you just one monochrome. Monochrome is a single color one, single color. Okay, and B is non-PL filtering image. So here is a PL filtering. So he's using some filter to process the image. And B is non-use this one. And C is the gross eggplant. Okay, C is the grossing eggplant. And D is partially dual eggplant. So D is another, so you can see it's not so clear compared with the C image one. And E is a Rutan fluid monochrome image. E is a Rutan one. And F is a Rutan fluid fluorescence image. So compare E and F, you can clearly see like this one, right? Let's emphasize the image, especially on the Rutan part of the fluid. Okay, and G is the putting fluid, and F is a normal fluid. So you can see they are a little bit different. And I is the X-ray image in G. Okay, so G is maybe is a damaged one, and their X-ray image will look like this one. H is a good one, a good fruit, and their X-ray image will look like this one. Okay, so from a common image, visible image, camera image like H and G are not easy to tell on the damaged one, but by using an X-ray image shown in I and J, then you can see they are very clearly separate for their damaged part. So they say here that 14.7 A and B show a comparison of polarizing filtering image and non-polarizing filtering image of green apple. And A have no headerton, and 4 points are observed on the Apple service. And B, and these two polarizing filters were used in front of the light device and the camera lens, which are adjusted to eliminate the halogen on output image from the camera. And as for lighting device, halogen lamps are frequently used so far because of their high brightness, higher color rendering, and cheaper price and long shelf life. And C and D is observable. The left eggplant have much halation and is predicted to be soft and fresh. The right one has a partially dual surface, especially near the blossom end. And sensitivity of the monochromator CCD usually range from visible to infrared region, and basically is from 400 to 1000 nanometer sensitivity is available now. Okay, and E and F show the monochrome and fluorescence image of the rotten orange fruit. And Curata in 2009 construct a new machine vision using white and UV LED to obtain color and fluorescent image by one camera. Okay, so because we try to using one camera and to separate the good and bad fruit. Okay, and G and H show monochrome image of riding putting orange fruit, where the I and J show X-ray image of this fruit, and the X-ray tube voltage was 50 to 70 keV. X-ray CT technology has recently advanced so much and is expected to have practical use online to detect a small size problem, such as the mosaic point or insect egg and young worms in fruit. Okay, so it's very promising, or we can expect many applications maybe a couple of years later that we're using this kind of non-destructive technique to identify the damage or the worm or insect damage on our fruit. So the finally is this summary. So there are many farming operations: field management, seedling production, crop management, harvesting, and grading. So in the operation, grading and its pre-processing operation is in post-harvesting has a special role to add product information and to collect many kinds of information on production stage, which can create food safety and security on traceability one. Okay, so post-harvest is very important, especially when we apply many automation technique on them. Okay, so that is for this slide. The chapter 14, we finally finished them.